Identify, you guys are probably going to need to move over a little bit, find somewhere else to move. So identifying inverse proportion from the equation. So if you have the equation, identifying the inverse proportion. So we already talked about x, y equals k. The other way of doing that, go ahead. The other way of doing that is, think about it, if you got y by itself, you divide by x on both sides, y equals k over x. So if you want y by itself, y is oftentimes supposed to be by itself in equations when you find things. Remember, you guys probably remember back to when we were talking about, what was it? Blank is proportional to something, something, whatever else. Whatever the first one they listed, that was always y. That was always the dependent variable, because the y depends on what those things over there are. So if you look on bottom of page 279, then tell whether the equation represents an inverse proportion. If so, find the constant of proportionality. So 1/2 y equals 5 over x. 1/2 y equals 5 over x. I'm going to put this black line and switch my color, because this purple stuff is important. This purple stuff is just what we're doing for the example. So I either want y and x together, or I want y by itself. Y and x together, or y by itself. Which one's easier? Yeah, y by itself. So they're already there, almost. So what do we do? What? How do I get rid of a half? It's multiplying by a half. How do I get rid of a half? What? How do you get rid of dividing by it? How do you get rid of multiplying by something?
Divide by the reciprocal.
Divide by it, but it's the reciprocal. You can't divide by a reciprocal, so you can't divide by it, so you have to multiply by the reciprocal. 2 over 1, 2 over 1, cancel each other out. Y equals 10 over x. Ding, 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 ding. Look, we got it. But if we wanted to, can we get it this way too? You should definitely be able to. If you can get it one way, you can get it the other way. Because we already showed, if you have this, you can go back in this way. So if you have this, you should be able to multiply by x on both sides. Multiply by x. Multiply by x. I'm going to put this in yellow so that we know that's the actual thing we're supposed to have. Multiply by x. Those x's will cancel each other out. So then we have x times y. It's not supposed to be in yellow, but x times y equals 10. What's your constant of proportionality, or your constant of inverse proportionality? What's your constant for this one? 10. And so which one of these is probably better for understanding what my constant is? This one? I would say this one, because here, the way that you guys are always using it in those tables, you do x times y equals 10. And so when you do that in these tables, you're always going to do x times y is 10, x times y is this, x times y is whatever it is. So this is always the one I would defer to. You might even say it's the gold standard. Thank you. So you're always going to want to defer to that one. Guided practice, 3/5 y equals 6 over x. And then y minus 3x equals 5. X equals 5? Yeah. So, right here, what do we do? What did we do last time? You had y times something. Yep, multiply by reciprocal. So 5 over 3, or over 3, not over 5. 5 over 3. Y equals, anything that we can cancel here? What? Yep, this becomes 1, this becomes 2. 2 times 5 is 10. 10 over x. Or, because we know we can multiply by x on both sides, xy equals 10. Is that a coincidence that we got the exact same answer as before?
Yeah.
Yeah, it's totally a coincidence. You just happen to have different answers, different questions. But yeah, the answer is 10 here still. What about here? What do we do? Remember, we either want to have x and y together or y by itself. Which is easier?
Y by itself.
Y by itself. So what do we do to get y by itself?
Oh, you have to.
Attention staff,
Okay.
not only was it donut day this morning, but good news, it's corn dogs for lunch and it's free lunch for staff. So feel free to come on down and have your corn dogs and your mac and cheese and baked beans when your class comes
If
through.
you're listening to this, important. All right, what do we do to get this by itself?
Reverse what's being done.
Yeah. So you mean that?
Yeah.
Okay. And then what?
I don't
How do we get rid of adding a number?
We.
Something.
No.
Okay, adding a negative number. How do you get rid of adding a negative?
You.
What's the opposite of a negative?
Positive.
So instead of adding a negative, you add a positive 3x. It's okay, numbers are hard sometimes. Y equals 5 plus 3x. Is it good?
Numbers can be hard when there's parentheses around it with the negative sign and X behind it. Yeah.
It can be. What do we, is it a constant? Is it an inverse proportion?
No.
No. Anytime you've got this little adding thing right here, that messes everything up.
Yeah.
You're never gonna have, unless it's something where it simplifies and it consolidates down to things, you're never gonna have something that when it's adding, it's actually gonna be an inverse proportion. Never ever. Same thing, same reason for why it's never gonna be regular proportion. Alright, then bottom of page 280 or midway through page 280, it talks about you see it starting going down, 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 down. That's what an inverse proportion looks like as a graph. It should look something like, and it gets closer and closer and closer, but it's never gonna get there. Getting closer to the 0 point, but it's never gonna get
But if
there.
it's
So,
always getting closer, then it'll get there sometime.
nope, it never does.
Is it getting closer though?
Yes, it is getting
Always?
closer. So think about it this way. This is actually a really good way to say it. Let's say I'm going from me right now. I'm going halfway to my desk.
Yeah.
So if I go halfway to my desk, I'm right here. All right. What if I go halfway to my desk again? Halfway to my desk again. Halfway to my desk again. Halfway to my desk again.
Eventually
Halfway.
you're gonna get there.
No, eventually I'm never going to get there because there's always going to be some distance between me and the desk, right? If there's always going to be some distance between me and the desk, and I'm going half of that distance over and over and over again, I'm never going to get there. I'm going to get incredibly close, but I'm never going to get there.
Think about it this way. Could you actually do that right now if you
Atoms.
wanted to?
Number one technically is atoms.
What?
Technically, you're not touching anything with the atoms.
Okay, yeah.
Okay, alright.
You're getting all sciencey on me now.
Hold up.
Yes.
Is there like a molecule that you, or like, you know, like, there's how many atoms between me and you? There's like, I don't even know, so many.
Billions, yeah.
So we're getting closer and it cuts in half every time.
Sure.
When you get close enough, you can't go halfway because you cut an atom in half?
Technically, there are smaller parts inside of an atom. I don't know, like cutting it in half, I don't know that you
Yeah,
could
because you have to
necessarily.
move closer.
Ooh, we broke
So you're not,
science.
you're cutting the distance in half. Distance is not an actual, like, 3D thing that you can touch. Alright, we're moving back into this. So, anyways, in this one, it's not like you're necessarily getting halfway in between there. Well, actually, it kind of is. But you can see in there, they've got the chart where it's got 1, 120, 2, sorry, it's supposed to be 2, 60, 3, 40, and so on and so forth. It's actually similar numbers that we looked at, I think it was yesterday, or no, 2 days ago. So you find the same thing over and over again, your constant of proportionality, or your constant of inverse proportionality here. It still says in the book it's called the constant of proportionality, but I like to sometimes call it the inverse one because remember it's for inverse proportion. Your constant of proportionality for what for these?
It is 120.
Yep. And that's easy enough to figure out. If you look over on page 281, it says interpret the graph of an inverse proportion. So A, find the constant of proportionality graphically, then write an inverse proportion equation. So they've got a point 212 on there. So automatically you know what is the constant of proportionality.
120.
No, on page 281.
Oh, yeah.
They have a point on there that's, hey, 2 over and 12 up. 212. Think about that. That would be like 212 on this graph, except this was the graph from the last problem.
24.
24, because anything that's there, if they're telling you this is an inverse equation, then you automatically know. Any point, any dot you give me on here, doesn't matter what it is, all of them are going to multiply together, because that's how inverse proportions work. They're really nice that you can just say, hey, I'm going to have that. So 2 times 12 equals 24, so I know my k value is 24. So if I then want to write an equation, so that's the first part, if I want to write that equation, remember, equation is either xy equals k, or y equals k over x. What's my k value? You just told me. What's my k value? 24. 24, or you can write it like this. Either one, doesn't matter. That's what you do for it. Done. Very simple. That says, explain what the point 212 represents in this situation. This is where you actually got to look on the graph. So on the bottom it says, number of window cleaners. And over here it says, number of hours. What?
She didn't think my notes were good.
You didn't take notes very good?
No, I did. She didn't think so.
Oh, I'm gonna take her word for it. So that means it took 2 window cleaners 12 hours to clean all the windows, whatever it is. So going by that, if it took 2 window cleaners 12 hours, it would take 1 window cleaner how many hours?
24.
Yeah, so then you'd have the point over here of 124. I mean,
But if you're
the
thinking about
24 would be way up higher.
If you're thinking about it logically,
Yeah.
he probably worked faster because he's alone with no distractions. So it'll probably take him about 20.
It's possible, but remember, so this right here, this is more of like theoretical math. It depends on who you're working with, because some people, like, it's the same thing for like a sports team, right? You can say, hey, this person has this many points a game, this person has this many points per game, if you're saying basketball, for example. That doesn't mean if you put them together on different teams that it's going to work out that way. It's like, how is their chemistry? But this is just saying, in general, if you have people of equal ability, all the other stuff, because chemistry you can't really plan in that way. If you have all these people of equal ability, the more people you have, it's going to get done faster. And if that's what you really want. Now, the way you build the team, or the way you build the window cleaners, quote unquote team, organization, whatever your company, whatever you want to call it, that's got something else.
I'm gonna be a window cleaner.
All right, last one, guided practice 5. We'll do this in class because it's super easy. Constant proportionality in the graph. What is it? It's got 1 point on it. 610. What's the constant proportionality?
60.
Yep. So then the equation would be
That y something.
what's the equation going to be?
Y equals 60 over x.
Or
xy equals 60.
boom, bingo, you win. And then it says for that one, it's the number of volunteers and hours. So that represents what then?
What?
Number of volunteers and hours. It's still page 282. So what does that represent?
60?
How many volunteers can clean the beach in how many hours? You gotta look on the graph. This is the number of volunteers, that's the 6. Number of hours, 10.
Volunteers in 10 hours.
Yep, 6 volunteers in 10 hours.
I couldn't do it.
And that's it for today.
Yay.